The pop quiz is related to the nature of the light. In the first question, in an experiment to demonstrate the photoelectric effect, ultraviolet light is incident on a metal plate. The photoelectrons are released from the plate with a maximum speed of 3.5 exponent 5 meter per second. Calculate the energy of these photoelectrons in electron volt. So first, which form of energy these photoelectrons will have? They will have, as they are moving, they will have a kinetic energy. So first we'll find the kinetic energy by using a formula. The kinetic energy is half mv square. So it will be half. M is a mass of electron. You don't have to memorize. This will be given in exam. The constant values. So mass of electron is a constant factor. You don't have to memorize, which is 9.11 into 10 to the power minus 31 kg. Multiplied by the speed at which this electron is moving. So this electron is moving at a speed of 3.51 into 10 to the power 5 and then square because it is half mv square. When we use this formula, we will, because we'll get the unit, the base unit and the unit for energy, not the base unit, the unit of energy will be joules. So when we simplify this, we get 5.6 into 10 to the power minus 20 joules. How to convert into electron volt? So we have 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So if we want to convert 5.6 into 10 to the power minus 19 joules into electron volt, so X. What we have to do, we just have to cross multiply. So means this 5.6 exponent minus 19 divided by 1.6 exponent minus 19. So when we divide them, we get 5.6 exponent 20. This was, and this is minus 19. So when we divide, we get 0.35 and the unit will be electron volts. So this will be the energy of the photoelectron in electron volts. The next question, the table shows the typical values of the work function. Yeah, mass of electron is fixed, which will be there in the constant value sheets, that it is 9.11 into 10 to the power minus 31. You have to use from that constant value. The table shows the typical values for the work function for 4 different metals: magnesium, aluminium, zinc, iron. Ultraviolet light is used in the experiment, had a wavelength of 310 nanometer. Deduce which metal most likely have been used as a metal plate. So the idea is that, look, according to the Einstein photoelectric equation, the energy of a photon, which is given by E, when this photon strike the metal surface, the electron will move out. So the energy of the photon is equals to work function plus the kinetic energy, which is half mv square. And we already worked out the kinetic energy in the previous part. We worked out the kinetic energy in joules. So energy minus the energy of a photon minus the kinetic energy will give us the work function. And the question is, which metal are most likely to have been used for this? Like, means we'll just work out the work function, the minimum possible energy. And then we'll compare with our result. So in how to work out the energy of a photon, the wavelength is given. So energy of a photon, there are 2 formulas: E is equals to HF or E is equals to Hc over lambda. But because the wavelength is given, so we use the second formula, E equals Hc over lambda. So H is a Planck constant. Again, this constant value will be given to you, 6.64 into 10 to the power minus 34. C is the speed of a light, which is again a fixed or a constant value, 3 exponent 8, divided by wavelength. Wavelength is in nanometer. So you have to convert into meter. So you will write 310 into 10 to the power minus 9 meter, because nano means -9. So when we simplify this, this will give us the energy of the photon, which strike the metal surface. So energy of a photon is 6.42 into 10 power minus 19 joules. And in the previous, we already worked out the kinetic energy of the photon, kinetic energy of these electrons. We worked out using a formula half mv square, and the kinetic energy for this electron, it was 5.6 into 10 power minus 20. That was the kinetic energy. So if we need the work function, so the work function is the energy of a photon minus the kinetic energy. So energy of the incident photon is 6.4 into 10 power minus 19 minus the kinetic energy of the photoelectron, which is 5.6 into 10 power minus 20. This will give us a work function. So when we simplify this, like subtracting the two values, you will get as 5.86 into 10 power minus 90. 5.87. So 5.87 into 10 power minus 19 joules. So which metal is having, we'll compare with the table which is given to us. So 5.8, which one it match with? So it match with magnesium. So magnesium is likely used here, because this word function matches with the metal magnesium. Is it clear, this one? The second part. The next is the electrons are only emitted for a given metal surface if a frequency of an incident is above a particular value. Explain why. Basically, here what you have to do, you have to explain the particle nature. So what actually happened? One electron absorbed one photon at a time. That is the first thing. So you have to learn these points. You have to memorize whenever. First thing, one electron absorb one photon at the time. Then there is a minimum energy which we need to remove electron, or the work function is the minimum possible energy which we require to remove electron. And if the energy of photon or the frequency is more than the work function or a threshold frequency, as a result, the electron will emit out. But if the energy of the photon or a frequency is less than the work function, then there is no photoelectric effect. So, like, the photoelectrons are only emitted for a given metal surface if the frequency of incident radiation is above the particular value. So what is the reason for that? Because for every metal, there is a work function. And related to a work function, there is a minimum frequency, which we call a threshold frequency. And energy of a photon E is equals to HF. So if we use a high frequency photon, means it will have a high energy. So when we increase the frequency, if this frequency is higher than the minimum frequency, then electron will come out. But if this frequency is less than, then there is no photoelectric effect. So photoelectric effect only happen when the energy of the incident photon is above the, or frequency of the incident photon is above the minimum value. Minimum value of energy or minimum value of frequency. If it is equal also, then it will also happen. Even if energy is more than or equal, yes, there will be a photoelectric effect. If energy is less than, there is no photoelectric effect. Student makes the following statement: it does not matter what value of a work function is for a particular metal, the photoelectron can always be released if the intensity of incident light is enough. Criticize the student statement. So what is the criticism? You will say student statement is not correct. Why student statement is not correct? Because if we increase the intensity, it will increase the number of electrons, but not the kinetic energy. And if we increase the energy of photon, here also it was photons. And if we increase the energy of the photons, what will happen? It will increase the kinetic energy. But the number of electrons remains same. If we have to criticize this statement, when we compare the statement intensity, increasing intensity means like more photons will be there. Like if this was a metal surface, when we say like two metals with two identical metals, if we say we increase the intensity, what does it mean? Means more photoelectrons are there. More photons are there. I mean, so more photons, more electrons will release. But the speed at which, like example, if this electron is released at 10 joules, this will also be released at 10 joules. So increasing the intensity will increase the number of photoelectrons, but not the kinetic energy. Intensity does not affect the energy in terms of particle nature. So that's why student statement is actually explaining a wave nature, not the particle nature. Question 2, the diagram shows the energy level of atoms of hydrogen. An electron is in the energy level of minus 13.6 ground level. A photon interact with the electron. Why this interaction cause the emission of another photon? So electron is there. Like electron initially in this level. They are saying it interact with a photon. So when the electron interact with a photon, this electron will absorb the photon. And after absorbing this photon, it will jump to higher level. And it depends on what is the energy of a photon. It can jump from, like, it can skip the levels as well. It depends on the difference. But when this electron return back, it will release that photon back again. So what is the reason for that? When this electron will interact with the photon, it will absorb this photon and it will jump to the higher level. When it jumps to the higher level, when it returns back to its ground state, it will release a photon, which is equals to difference in the energy of the two levels. So why this interaction cause the emission of another photon? So reason that electron absorb the photon, and as a result, it will jump to higher level, and then it return to the ground state, release the photon, equals to energy equals to the difference of the energy of the two levels. But it's of 2 marks. That's why we don't have to write the values here. A photon with a wavelength of 318 nanometer, determine the energy. So how to determine the energy? We have the formula E is equals to HF is there, or E is equals to Hc over lambda. That we use to work out the energy of a photon. We have the wavelength, which is 280. So E, the Planck constant, 6.64 into 10 to the power minus 34, the Planck's constant, multiplied by speed of a light, which is 3 into 10 to the power 8, and divided by wavelength 280 nano means, don't forget to convert into meters. So 10 power minus 9, that will be a nanometer. When you divide, you will get this energy in joules first. So this will be 9.12 into 10 to the power 19 minus 19 joules. Then use a relation like 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So if we have 9.12 into 10 to the power minus 19 joules, how many electron volts? X. We just cross multiply, means divide. So you get energy in electron volt, which is 5.7 electron volt. A similar question we did the first one as well. So this is the same way. Explain whether the atom of hydrogen could emit a photon of this energy. How you'll identify? You have to check the transition, like 5.7 electron volt. Any transition, like any difference in the value is 5.7. And ground state is this, like electron is in this ground state. So it has to return back to this level only. According to, because the ground electron should return back to the ground state. So we have what we have to do, we have to check these differences to the ground state. Like example, 13.6 and 3.4. So what is the difference? 13.6 minus 3.4. So this difference, like this energy will be 10.4. And look, others are obvious, it will be higher because this is the smallest one. Between the second and the first is the smallest. Other length of arrow is longer, so it is obvious the other values will be more than 10.2. So if you want to check, you can check, but by looking at this, you can identify if greater length of the arrow means more energy will be released. So the minimum energy it can release is 10.2. So whether the atom of hydrogen could emit a photon with this energy, so you will say no, because the minimum energy photon which it can emit can be 10.2 electron volt. And because these energy levels are discrete, like there are quantiles or discrete fixed positions are there, you don't have like all the values, it's only a fix. So minimum is 10.2. So other values will be higher than 10.2. It cannot be less than 10.2. And certain transitions are possible between the energy levels. In part C, photon with energy 1.63 exponent minus 18 joules is incident upon a surface of a metal. This is related to photoelectric effect. The metal releases an electron due to photoelectric effect. The maximum possible speed. Look, first energy of a photon, it is absorbed, work function, and then they will have a kinetic energy. So first we can work out the kinetic energy, and then from kinetic energy we work out the speed. So energy of an incident photon is equals to work function plus the kinetic energy. Energy of an incident photon is 1.63 into 10 to the power minus 18 joules. Keep one thing in mind, whenever you are using these formulas, energy should always be in joules. You cannot substitute in electron volt. It will be wrong. So energy should always be in joules. So equals to work function, the minimum possible, that is 5.89 into 10 to the power minus 19 plus the kinetic energy. We subtract them to get the kinetic energy. So it will be 1.04 into 10 to the power minus 18. Then we have kinetic energy is equals to half mv square. So 2 into kinetic energy divided by m in a root will be equals to v. So 2 multiplied by kinetic energy 1.04 into 10 to the power minus 18 divided by m, the mass which is constant 9.11 into 10 to the power minus 31 kg. Take in a root, you will get the value for v, which is 1.5 into 10 to the power 6 meter per second. So that's a speed at which this electron will move out. Is it clear, this one? Explain why photoelectric effect demonstrate light behave as particle rather than wave. This is a very important question, important type of a question. You have to memorize this answer. Like the points which you have to mention. According to particle nature, so one side is for the particle nature. According to particle nature, one photon, like one electron absorb one photon at the time. Absorb one photon at a time. And there's a minimum possible energy we need to remove electron according to particle nature. And these electrons are released instantaneously. Like the moment, if the energy of a photon is more than the work function, the work function, what will happen? Electron will release instantaneously. And if we change energy of photon, what will the effect? It increase the kinetic energy, but not the number of electrons. And if we increase or if we change intensity, like more photons are there per in 1 second, intensity of the photons, it will increase number of the electrons, but not the kinetic energy. So these are the points you will always include whenever you have to justify that it has a particle nature rather than a wave nature. Question 3, a teacher demonstrates the behavior of electrons traveling through a graphite. An electron beam is directed through a thin piece of a graphite towards a fluorescent screen, and we observe a diffraction pattern. Look, if electron was behaving like a particle, then what should happen? If you remember the Rutherford experiment, that most of alpha particles were able to pass through, few of them deflected and few bounced back. This should be the observation. Like only certain points should be visible. Certain dots should be there, certain regions should be there where we observe the electron. But here what we observe a diffraction pattern, like a bright, then dark, then bright, then dark, then bright, then dark. So means we observe a diffraction pattern. So what actually happened? this electron is not acting like a particle, it is acting like a wave. So when this wave passes through this gap, it diffracts and interfere. And that interference pattern we see on the screen. So what this demonstration actually shows, it shows that electron is not behaving like a particle, it's acting like a wave. So the demonstration can be used to make a conclusion about the behavior of electron and structure of graphite. State these conclusions. So first thing, electron is acting like a wave, can act like a wave, and why? Because in this case, the electrons are diffracted when they are passing through a graphite. And diffraction, the wavelength which is associated with the electron matches with the gap size or the particle spacing in the graphite. That's why the diffraction is observable or happen. And it also shows that graphite is having a regular structure as well. So the points you will mention, electron is behaving like a wave. And why it is behaving like a wave? Because it diffract, and diffraction is a property of a wave. And why it diffract? The wavelength associated, or you can also say the de Broglie's wavelength, because when like wave particle duality, if the particle, if a wave is associated with a particle, so we call that as a de Broglie wavelength, or you can also say a wavelength of electron is similar to spacing between the atoms, which produce diffraction pattern. And interference. Is it clear that this electron in a diffraction, electron act like a wave instead of acting like a particle? In part B, the electrons are accelerated through a potential of 24,000 interacting with the graphite. State the work done. How to calculate work done is force into distance. But in electricity, what is the work done? Work done is voltage. Basically, voltage is work done per unit charge. So we need the work done in electricity, it is voltage into charge. How much voltage is there? 2400. And the charge of electron is fixed, which is 1.6 into 10 to the power minus 19. So when you multiply them, you will get approximately 4 exponent minus 16 joules. So work done is force into distance, but in electricity, voltage is work done per unit charge. So work done is voltage into charge. Calculate the maximum velocity. The work done, the work which we did here is converted into kinetic energy, and kinetic energy is half mv square. So after getting this answer, like it should be approximately 4 exponent minus 16. So this value should be, the work done is 4 exponent minus 16. Half the mass 9.11 into 10 to the power minus 31, a constant value, and then v square. So just you have to simplify, 2 will be multiplied, this will go there in division and take a root. You will get the speed at which this electron is moving towards the graphite. The accelerating potential was then increased. How the pattern of a screen would change? Look, we have the formula lambda is equals to h over mv. If we increase the accelerating potential, because like voltage is work done per unit charge, so work done is voltage into charge. So if we use the accelerating potential, means the work done will increase. If the work done will increase, what happened to kinetic energy? The kinetic energy will also increase. And if the kinetic energy increase half mv square, mass is constant. So if the kinetic energy is increasing, it means the speed at which this electron is moving, that will also increase. So when we increase the potential, the speed of the electron will increase. If the speed increase, what happened to momentum? The momentum will also increase. So the wavelength which is associated with the electron will get shorter. And if the wavelength gets shorter, the diameter of these circles, because now the gap size is larger, because if you remember, like if you have this, this is a gap, and if we reduce the wavelength, so if the wavelength is decreasing, diffraction pattern, it will be like less diffraction. So as a result of a smaller diffraction, what will happen? The distance between the maximas will decrease. If we have more diffraction, then the spacing between like maxima, then minima, then maxima will be greater. If we have smaller diffraction, like smaller spreading, so this spacing will decrease. So you can say spacing of the circle or diameter of the circle or spacing of the maximas will decrease. Is it clear? This part? Some students investigate the photoelectric effect. They use a piece of magnesium ribbon inside a cylinder of a copper gauze. Then there's an air gap between the copper gauze and the magnesium ribbon. The copper gauze is connected to a positive terminal of a battery, and the magnesium ribbon and a sensitive ammeter is connected. The student made the following observation: when the light from a UV lamp was incident on the gauze and a ribbon, a current was detected. When a polarity of a power supply was reversed, the current decreased to zero. Means, so it means like electrons are moving from, when they change the polarity, this is negative and positive, so this will be negative, and this negative will repel the electron, so that's why the current is decreasing. So means the when and light, ultraviolet light falls on both copper gauze, means copper net, and the magnesium ribbon. But it means magnesium is emitting out electrons rather than copper. Because when we change the terminal, the electrons are completely stopped. So explain the observation, 6 marks are there. Like what are the points you will include? First thing, you will mention like light, because photoelectric effect happen here, or photo, because of electrons are emitted because of photoelectric effect, in which light is acting like a particle, not a wave. Then the energy of a photon, if the energy of a photon is more than the work function, then the electron will be released. Why they provide, it can be in the beginning, the first, when they set up, the magnesium is negative and the copper is positive. When both, like ultraviolet light falls on both copper and magnesium, electrons are emitted. But how we know which direction, which metal is emitting out electron? Because there is a current. But when we change the terminal, like we make this negative and this positive, so then there is no current. So it means the electrons are being stopped. So the electrons are actually moving from magnesium to copper rather than copper to magnesium, because these photoelectrons are being stopped by the negative terminal. When the polarity is reversed, the current decreased to zero, means the copper is negative now. So the current, like charges repel each other. As a result, no current is there. So you will mention the points like electrons are emitted from the magnesium ribbon, and the energy of a photon is more than the work function. That's why they are emitted out, and the energy of these photon, kinetic energy, depends on the energy of incident photons. And when the polarity is reversed, so it means the work done on the electron, like electrical work done and the kinetic energy equal. That's why there is no photoelectric, electrons are not able to move, so the current will be zero. So these are the points you have to include in your explanation. Then student reconnect the circuit so the current was detected when ultraviolet light was incident on the gauze and ribbon. Student replaces the original lamp with ultraviolet much greater intensity. So if we increase the intensity, as we know, if we increase the intensity, there will be more photoelectrons. Number of electrons will increase, but not their kinetic energy. So as the number of electron will increase, so there will be a greater flow or greater number of electrons or more current will be there. Because as we increase the intensity here, so like low intensity, maybe 2 electrons were moving, but high intensity, more electrons will move. So as a result, more electrons, high current will be there. So the reading of the ammeter here will increase. And then the ultraviolet lamp was replaced by a laser which emit wavelength 633 nanometer. Deduce whether the photoelectric effect will occur. The work function is 3.7. So what you have to do, you will use the formula E is equals to phi plus Ke. Energy of a photon you can get from this by using a formula E is equals to hc over lambda. This will give us the energy of a photon. If we need the work function is given, but we have to identify whether this electron will be emitted out, like this will work function value is given to us. So we have to compare. So using the E is equals to hc over lambda, we get the energy of the photon, energy at which the photons are emitted out, which is 3.14 into 10 to the power minus 19 joules after substituting the values. Then work function is given. This is the energy of a photon, 3.19, and work function will convert into electron volt will convert, like multiply by 1.6 into 10 to the power minus 19 joules. When we multiply, this will convert into joules. So that will be 5.92 into 10 to the power minus 19. So 5.9 into 10 to the power minus 19 and 3.14 into 10 to the power minus 19. So energy of the photon is less than, like energy of a photon is say 3.14, but the work function is 5.92. Both have the same coefficient. So can this electron come out? No, there will be no photoelectric effect. So you will just compare the energy of a photon with the work function. If energy of a photon is more than the work function, yes, there will be a photoelectric effect. Otherwise, there is no photoelectric effect. So in this case, there will be no photoelectric effect. So this was a pop quiz related to nature of the light.